Okay. All right. Well, do you want to go ahead and get started and ask questions?
Yes.
Okay, go ahead. Yeah, what is your first question?
Um, I have to look at the problems first. Hold on one second.
Oh, that's okay. Yeah, Marcy, you can go ahead with your question. Oh, there you go. Okay, yes, you can actually fax it in. I have a fax number in the syllabus. Let me go and look it up real quick, and then I can type it into the chat window. Hang on. Okay, oh, here's the fax number. If you don't have a fax machine, you could also take a digital picture if you have a digital camera or like a camera on your phone or your kids' DSs or gadgets. That'll work too if you attach it as a image file like a JPEG or TIF or PNG. You can attach that to an iCollege email.
I tried attaching it to an iCollege email. I took a picture of one of the graphs I drew, and it said it was too big.
Oh, okay. I don't know if you could reduce it. Sometimes if you have like a photography program or a Windows image program or something, it'll allow you to save it, to put it in a smaller format. And if you send it by snail mail, so that would work too. Yeah, let me type in see where you would send it to. Okay, hang on. So if we turn these labs in past the due date on the calendar, are we getting points off? No, actually, the due dates in the calendar are more like guidelines to keep you on track. So you want to work on one lab a week. Um, but as far as the absolute drop dead due dates, if you turn in the first four labs on the day that the lab midterm exam becomes available, then that'll be fine. I also have a catch-up week in the calendar. Yeah, let me type in the address real quick, and then I'm going to look up that date when the lab midterm exam becomes available. So until then, if you get stuck with one lab, you can always start working on another while you're waiting for feedback on how to get unstuck. So yeah, it's a little bit more flexible. Let's see. Okay, so the address is Auricula Hayes at Georgia Perimeter College, Science Online, North Indian Creek Drive. Oh, I think it's 555 North Indian Creek Drive. And then Clarkston, Georgia 300. think it is 2-1 for Clarkston. Okay, so that would be the snail mail address. And let me go and look up the, well, let's call it the drop dead date for the first 4 labs. So that would be Math Review, Celestial, Coordinates, Kepler's Laws, and the moons of Jupiter. Okay, hang on. Okay, just go to February. That would be February 20th. So that you would have until then. And we have a catch-up week, February 13th through February 19th. So any labs that you haven't turned in then, you can finish up and turn in during that week. Okay, so February 20th. And the week before, I'm going to type that in too, is catch-up week, where you can work out any labs you haven't submitted yet. All right, I'm ready for the next question.
Okay, I'm having trouble identifying the ecliptic and the celestial horizon.
On the Your Sky website?
Yes.
Yes, okay. Let me see if I can quickly see how I might do that. Okay, I'm gonna go to that program. I don't know if you can see anything at that point, but I can try to capture an image and then bring it back into Wimba. I'm gonna open up the eBoard, which should come in. Or something else that I could try to do is I could try to share my desktop. Let me see if that works. Then you would see everything that I see. Let's see. Okay, so I've just clicked on begin sharing, and let's see.
Excuse me. It's not the celestial horizon. It's the celestial equator.
Okay. Yeah, let me see. Do you see my desktop now?
Yes.
Okay. Let me go ahead and minimize that. Minimize that. Okay, I'm going to go to the celestial coordinates lab module. Okay, and to the simulation of the night sky website. All right. Okay, and let me set it for nearby city. So we can set it for Atlanta. Okay, and okay, well, might as well set it for now since 8:20. That's pretty close to 9 p.m. So let's update this. Okay. And yeah, right now we're all zoomed out. So let's see, you see the celestial equator is this light blue line. Can you see my cursor? The
Yes.
hand that I'm moving across? Okay. So that's the celestial equator. And there's even a planet on it. Okay, and then the ecliptic is the dark red line that I'm moving my hand along now. Okay, and then the lab will ask you for constellations that you can see. So you want to go to view horizon at this observing site. Okay, so right now this is what we would see, and we're looking straight north. So we're seeing a couple of constellations here. We see Ursa Minor, and we see Cepheus. Whoa, there's some sort of feedback. Okay, good. Yeah, that's better. And then we see Draco. So those would be three constellations that we see if we would look north. So the yellow words are the constellations, and the red words are the stars. So Polaris here is our North Star. So that would be almost exactly at the North Celestial Pole. This cross here, light blue colored cross, is the North Celestial Pole, and Polaris is almost right smack at it. I'm not even going to pronounce this guy here. Now, those three constellations we see at 9 p.m. tonight. Now, we can use the pan buttons. So if we pan right, scroll back down. So this would be the northeast. So we're going east now. We would see Leo minor, Ursa major, see if we keep going, Cancer, Canis minor, a little bit of Hydra. So you could pan all the way around and then pick 5 constellations, or 6, I think. I think it used to be 5, and in the 11th edition we've changed it to 6.
Now, will Polaris always be close to the North Celestial Pole, or will it vary sometimes?
Yes, I mean Polaris is pretty much it pretty much keeps its position. Well, in the celestial sphere, it's always near the North Celestial Pole. So all the stars and all the constellations keep their coordinates in the celestial sphere. We see them move because of the rotation of the Earth. So the only thing we might see Polaris do is wiggle just a little bit. But the other stars, well, let me pan back to the north. So we're looking at Polaris. Oh yeah, we can also go over questions 2 and 3. Yeah, just jumped right in and went to the second part with the where we picked the 5 or 6 constellations. Okay, so now we're looking back at Polaris. Yeah, if we change the time, see, I mean, right now it's 8:24, 8:25. The time that you're looking at is universal time. Universal time is 5 hours ahead of us. So if we wanted to set it for, let's say, 3 a.m., which is another part of the lab, we're looking at 6 constellations right now around 9 p.m., and then see if they are still, or how many of them, which ones are still visible 6 hours from now, then that would be 3 a.m. on the next day. So 9 p.m. would be 2 a.m. universal time. So if we go to 3 a.m., that's 6 hours later, so 2 plus 6, that would put us at 8. So we want to go to universal time, and we want to change that to 8 a.m. Well, actually, they just do it in military time. So I'm going to change that now to 8:00:00 and update. Okay, and let's just double check. Yes. Okay, and you can see how Polaris is still pretty much at the exact same position, because the North Celestial Pole stays at the same position. But what happened, can you tell what happened to Ursa Minor? How it has changed its orientation? See, it used to be, when we were looking at 8:24, which is pretty close to 9 p.m., it used to be almost exactly, aligned with the northern direction. We scroll down again. So, it sort of was in the northern direction. And now, oops, what did I just do? Oh, I may have zoomed in on it. Yeah, because I accidentally clicked it, I guess. Um,
I noticed that it looked like the constellations kind of moved to the west. I mean, the east a little bit, or the west.
Yes, yeah, the constellations, yeah, they move. So they circle around. I mean, if you look in the northern direction, they circle around the North Celestial Pole in a counterclockwise fashion. So they move from west to east when they're below the North Celestial Pole, and they move from east to west if they're above the Celestial Pole. But in general, if you're looking in the direction of the North Celestial Pole, they rotate counterclockwise around the Celestial Pole. See, I can even change the time a little bit more. So Polaris used to be pointing straight down, which was the north, and now 6 hours later, it's pointing to the northeast. So let me set it to, let's see, 8 plus 6, 14. See, we have to do military time with this thing. We can update that. Oh, wait a minute, that didn't do much. Well, let me get it back to the horizon view. See, I may just have to, I don't know if we can use the back button in the browser. That'll take us to somewhere else. I'm going to go back to the virtual, up to your sky, back to the virtual telescope. Okay, let me go up to my sky. Okay, here we are. Okay, we may have to just go through that again. Okay, we wanted to set it for, well, let's take a look at it now and then back it up, advance it 12 hours. Okay. Okay, so now we're looking at Polaris and Ursa Minor, and it's sort of pointing down towards our north point in the sky. Okay, now we're going to change it from 1:30 a.m. Universal Time to, so you wanted to get it 12 hours later. So there would be 13:30 and 45. So let's do that. Remember how Polaris and Ursa Minor look right now? Polaris is close to the north celestial pole. Ursa Minor is pointing down towards our north point. So let's click Update for 12 hours later. Okay. Yeah, and this shows that it's actually daylight now because we have a bright sky. But the only reason we can't see any stars during the day is because the sunlight is scattered around our atmosphere so much that we look at a blue sky. But yeah, if it weren't for the sun, then we would still see the constellations. But as you can see how the orientation of Polaris has changed, it has changed. Now it's pointing up in the exact opposite direction. But in the lab, we're actually not looking 12 hours ahead, we're just looking 6 hours ahead. So that would be 7:30 a.m. in Universal Time. I'm sorry, didn't mean to scroll all the way down. Okay, so that's what we were looking at earlier, that if we start now where Polaris was pointing all the way down towards the north point, and then we advance it 6 hours, Polaris was still at the north celestial pole, but Ursa Minor, the constellation that Polaris is in, has flipped up 90 degrees in the counterclockwise direction. And then 6 hours later, it's going to be all the way up. So the constellation of Ursa Minor is rotating counterclockwise around the north celestial pole within a 24-hour period. And if you look at the other constellations, we can just go back to now and look what Cepheus is doing, for example. So the constellation of Cepheus is right here. Let's back it up to right now. Okay, Cepheus is still on the upper left. So this would be right now at 8:30 p.m. And if we advance it by 6 hours, so that would be like 2:30 a.m. tomorrow morning, which just happens to be at 7:30 Universal Time. Then Cepheus has spun around a quarter of the way around the North Celestial Pole. So 6 hours later again, it'll be halfway around, and then another 6 hours later, it'll be 3/4 of the way around, and then 23 hours and 56 minutes later, it'll be exactly at the same position. But of course, 24 hours later, it'll have shifted 4 more minutes. Okay, so that's how the constellations move throughout the course of the night. Yeah, Kian, and then you had a question about the celestial equator, how to see that, or the celestial, the celestial equator or the ecliptic. We can see it in the general view, but we could also see it if we keep panning right or if we keep panning left. That is, as if we're turning, instead of looking straight north, if we look east, for example, after 2 clicks, I think, and this light blue line, that was the celestial equator. And the numbers that you see on the celestial equator are the hours of right ascension. So this would be 16 hours of right ascension, 15 hours, 14 hours of right ascension. And anything that we see, all the stars that are now in the vicinity, they are all within 10 degrees, either north or 10 degrees south of the celestial equator. So, if you're being asked in number 2, name one star on or very near it, then all these that we see right here would work. You could put down, just pick the one that you like best, Arcturus or Gemma here, that's easy to spell. I don't even know if I want to try to pronounce those here. Pulcherima or Corniforus, Unicolhi. Well, I don't know if you're laughing out there. This is always a crowd favorite here. I get that one a lot. Zubinel Ganubi. And if you're looking at this red line, at this view, you see the celestial equator here, the faint blue line. But this one, the dark red line, is the ecliptic. So this one would be good for question 3. There are stars, if we come up to the point in the sky where the celestial equator and the ecliptic are about to cross or intersect, then the stars that are near them are within 10 degrees of both. So Spica here would be a good example of a star that is near the the ecliptic, and also within 10 degrees of the celestial equator. So that star would work for both. Zubinel Ganubi would work for both, because we saw it fairly close to the celestial equator, which goes out here, but it's also very close or almost exactly on the ecliptic. Here's an interesting way to spell Jenna. That would be fairly close to within about 10 degrees of the the ecliptic. Okay, and then there's a question 4 here, the angle between the celestial equator and the ecliptic. So, does anyone have guesses about that?
That's the one I was stuck on.
Okay. Well, you can find the point. Well, now a different view might be a little bit better. If we go back to seeing the entire, we go back up to your sky, that's where we were. And it actually doesn't matter if we want to look from a particular place now or just at the celestial sphere in general. So we can just click on Make Sky Map. And there's one way of doing it with this celestial sphere, and that is find the point where the ecliptic is the furthest away from the celestial equator. And then we can click on a star that is very near it and find its coordinates. And actually what we're looking at, we want to look at the angle. So we want to look at a star that is on the ecliptic at the point that is further, when the ecliptic is furthest away from the celestial equator, and then read off the degrees, which would be the declination. It looks like right now we'd still have to move over a little bit, so we can just click on a point on the on the ecliptic. Okay, well, see how it was first. See, here we have the celestial equator at the bottom, and up here we have the ecliptic. Let's see if I can get it. Okay, it just doesn't want to give me the point where it's, you can see how the ecliptic is sloping down here. And if I click on the point where this is furthest away, then I get the other view where it is sloping up. So let's see if I click on, well, let's pick this NGC object. I mean, this is not a star, but it is an object that is in the catalog. So I'm hoping that I get coordinates for that one. I think I was clicking on this object here, NGC 1746. Wait a minute. Yeah, it's too bad that this ecliptic here doesn't have any dates on it, because we would look at the date where the sun has the summer solstice, when it is highest in the sky. That's when it is furthest away from the celestial equator. Okay, well, let me just click on this again. Okay, and the aim point right here above, well, would be 24 degrees. And we see that it's a little bit above the celestial, above the ecliptic. So if we look at, well, now we're at M35. Yeah, this is our aim point here, NGC 1746. So that's a little bit above the ecliptic. So the ecliptic wouldn't be quite at 24 degrees at that point. It would be more like 23.5 degrees. Does that number ring a bell? The 23.5 degrees?
Yes.
Yes, and that is actually no coincidence, because if you think about it, our Earth's axis is tilted by 23.5 degrees away from the vertical, if you will. So, if you look at the plane of our solar system, the plane in which the Earth revolves around the sun, and if you have a perpendicular to that plane, then our axis is tilted away from that perpendicular 23.5 degrees. But that also means that our celestial equator, because it is sort of stuck to our Earth's axis, it's just 90 degrees away from it. So the celestial equator is then also tilted 23.5 degrees away from the ecliptic. So that's why you can either, look up where the sun is, what is the sun's declination on the summer solstice, or you find an object in the sky that is really close to that point, like we just did. Or you can say, hey, wait a minute, the angle between the celestial equator and the ecliptic is exactly the same angle as the angle that our Earth's rotational axis is tilted. So for that question, you want to put down 23.5 degrees.
Which question was that one?
That was for question 4, what the angle between the celestial equator and the ecliptic is.
And that's 90, right?
That was 23.5 degrees.
Oh,
the angle
yeah,
between 90 degrees would be the angle between the celestial equator and either one of the celestial poles. So let me just check and go back if anybody has typed in a question. I don't even know if that's possible if you see my desktop, right? Or would you be able to type in a question? See, I don't know.
Yeah, I had a question about the, can you hear me?
Yes, go ahead.
Yeah, I had a question about, like when it's asking about the degrees, are we going to be changing the times on this, right? I'm just trying to get how to do the lab, question by question. Like like on question 2, it says locate the celestial equator. I can do that. Name one star on or near it. I can do that. Find one within 10 degrees north or south. So I just didn't see any. I guess they're in 10-degree increments on latitude.
Well, if you click on the star, let me just, since we have the ecliptic here and the celestial equator down there, it shows you the aim point. So the aim point would be the center point of the image or of that little window that you have. And first you have the right ascension, so there would be 5 hours and 12 minutes. Sorry, there's a phone ringing in the background. I'm just going to let it go to the answering machine. So 5 hours and 12 minutes and 10 seconds. And the degrees would be the declination. So 24 degrees would be the actual declination. And I'm saying don't worry about reading off the degrees, because you could look up the actual degrees for question 2 with the celestial equator, but then the how, if it's within 10, if it's north or south of the ecliptic, it would be a little bit harder to read from this program. It's easier to read from the program that they use at school, and they actually have a plastic model of a celestial sphere at school that they use, and it's a lot easier to read off of that one. So that's why I was thinking, online you can just tell me if it's north or south, and don't worry too much about the degrees. Yeah, let me go and see Aldebaran right here. So Aldebaran, I can click on it, and then the program will center the view on Aldebaran. Okay, and the degrees would be, so it would be plus 15 degrees, 29 minutes and 43 arc seconds above the celestial equator, because the celestial equator is at 0 degrees. Yes, in that sense, Aldebaran would already be further away than 10 degrees. Well, here, let's go to Bellatrix. It's one of the shoulder stars of Orion. And Bellatrix is at plus 6, so you would say it's north, 6 degrees north of the celestial equator, because it's at a declination of plus 6.
Oh, I see. Thanks.
Now, you also see the the ecliptic here, which is the dark red line. You could estimate and say, okay, if you wanted to give some degrees, if Bellatrix is about 6 degrees above the celestial equator, then it looks like it would actually be, well, 6, 12, it would be more like 15 degrees south of the ecliptic. If you wanted to sort of estimate that, because you know that this is about 6 degrees, and then, okay, 6, 12, 15, if you wanted to do that, but it would be okay for me if you wrote, okay, Bellatrix is north of the celestial equator, and it is south of the ecliptic. So for question 3, you could put also Bellatrix and then just write or circle that it is south of the ecliptic. Or you could pick a different star, for example, Betelgeuse. Okay, does that answer your question?
Yeah, this helps a lot, because I sometimes I tend to make things harder than what they are. So this really helps.
It's that, you're if you're not sure, you start second guessing yourself, and you get into this, oh my God, am I doing the right thing? And then I know what that feels like.
Yeah, and there's really no right or wrong answers. You're just wanting us to get the objective of the lab is finding these celestial coordinates, and we can choose whatever stars we want.
Yeah, I mean, there are many, many, many choices that are correct in this particular instance. Yeah.
Yeah, that makes me feel better too. And like I said, I think I was just making it harder than what it was. So I was so glad to see we're doing this WIMBA tonight.
Yeah. Well, and I mean, like I said, I have these fixed sessions, but we can also, meet when at any other time we can make an appointment, with any student, and then, just meet. Let's see, are there any other questions from the lab or math review lab for that matter, that you want to cover?
Yeah, I did have a question on your sky. Are we Are we leaving the latitude and longitude degrees alone? We're not putting anything in there, right? Is that right?
Let's see.
Yeah, when you first get started, like, can't we just click now and do the exercise? Do we have to keep changing the universal time like you showed us?
Well, okay, for the initial questions, you're just looking, for stars near the ecliptic or the celestial equator, or you're looking, number 5, just the right ascension and declination for Vega, Capella, the vernal equinox. And I mean, it says the small Magellanic Cloud, but for online, you can use the Andromeda Galaxy because you can look that up in one of the catalogs. Those stars and other objects, they always have fixed coordinates, and so it doesn't matter what time you look at the sky, their right ascension and declination will always be the same. It's just later when you go to question, let's see, 9, name 6 constellations that are visible. It changes, it depends on the time, what is visible when we are observing, if we see it above the horizon or not. Because, the Earth rotates, so we rotate through the celestial sphere and see different things at different times. That's when you want, okay, now, if you actually do the lab at 9 p.m., so if you do it right now, then you can click now, because the actual time right now is 9 p.m. But let's say if you do the lab some other time during the day, for example, tomorrow afternoon at 2 p.m., then you don't want to click now, because then it would have the equivalent of universal time, that's the equivalent of our 2 p.m., and that would be, let's see, +5, let's see, 14, because it's military time, 2 p.m. in military time would be 14 o'clock, so +5 would be 21, no, wait a minute, 19, yeah, 19 o'clock. So that would be more like, yeah, definitely not what you would see at 9 p.m. 9 p.m. would be 21. But of course, since we're in universal time, you'd have to go 5 hours ahead of that, 21. So that would be like, see, I think it would be 2 a.m. the next day. Okay, now we're all confused. Okay, so the best thing is do it right now at 9 p.m. and then I don't want you to get up at 3 a.m. But for the 3 a.m. tomorrow morning, just set the universal time to 3 plus 5. So that would be 8 universal time. So I'm actually advancing it to 8 universal time. So that would be the equivalent of our 3 a.m. the next day. Let's see. So of course we have to make sure that we're still looking at well, we need the above the horizon view, so I have to go back to your sky. And then set for nearby city. Atlanta. See, it keeps resetting. It keeps resetting back to, the default, which is now. See, and now actually happens to be, we're almost at 9 p.m. And you can see universal time, 9 p.m. is equal to 2 a.m. or 2 o'clock. It's 1:59. So that means unless you do it the lab right now, where you could use the now function, if you do it at any other time during the day, you want to click on universal time and then enter 2 o'clock there for the 9 p.m. observation. So that would be for question 9. Okay, and then question 10 is roughly how many of the constellations visible at 9 p.m. will still be visible above the horizon at 3 a.m. So if you translate that into universal time, since we're advancing by 6 hours and you have 2 a.m. or 2 in universal time, so add 6 hours to that. So our 3 a.m. equivalent observation in universal time would be 8 in universal time. Okay, let me just go to 0 here. Oops. And then click update. Okay, so this would now be, if you look at the date, 6 hours later at 8 universal time, which would be 3 a.m. our time. And if you look close to the celestial North Pole, those constellations will stay up. From where we are observing, they're circumpolar. But if you, for example, look at the south, let's just pan right a couple of times. Or if we look east, those constellations will rise and set. They will rise in the east and then set in the west. Over the course of a night. So if you pick constellations that are close to the south, the southeast, or the southwest, and you compare the 9 p.m. observation time versus the 3 a.m. observation time, then those constellations will actually change. So the further away you get from the North Celestial Pole, the more will the constellations rise and set. But the closer you get to the North Celestial Pole, the more circumpolar those constellations will be. So, for example, in number 12, name at least one constellation on the globe which would be visible for an entire 24 hours. What would be a good example?
Polaris?
Well, Polaris would be the star in that group. Yeah, Ursa Minor. So you want to put down Ursa Minor. So, yeah, focus on the yellow names. Those are the constellation names. So Ursa Minor would be the best constellation to pick. But even, you can pick, panning back to the northern direction.
Can you also do Draco?
Yeah, you could pick Draco. Yeah, I think that's just off to the east here. Cepheus or Camelopardalis, or down here is Cassiopeia. See, they'll come down and maybe part of them will vanish below the horizon, but most of them will stay up. So all these constellations that you see here, this was Draco here, they will be visible pretty much 24 hours. But of course, Ursa Minor is the safest one to pick.
Oh, that's right. The yellow ones are the constellations.
Yes, yellow ones are constellation names, and the red ones are the star names. Okay, and then I think we had talked about how the positions change. Or how you could do that. I mean, yeah, counterclockwise. They rotate if they're close to the North Celestial Pole. They rotate counterclockwise within a 24-hour period. And what you could also do with this program, we've advanced the time, but you could also advance the date. So if you wanted to look for question 14 is similar to question 13. I mean, question 13 was about how does it change during the course of one night, where you advance the time. But question 14 is how does it change throughout the course of an entire year. So at that point, you can just leave the time fixed and then change the date. So instead of January, well, let me put it back to the 2, which is equivalent to the 9 p.m. observation. Let's go back to 2. Okay, so this is what we would see right now. 6 months from now, let's not do half a year, let's do a quarter of a year. So instead of January 28th, I'm going to do, April. I'm just going to change it to 4, the month to April. Update. And look at that. How has the position of Ursa Minor changed? So we're observing at 9 p.m. at our location, but this is what it would look like in April. So it actually has changed by about the same amount. So whether we wait 6 hours in the same night, or we look at the same time each night and just observe 3 months later, that amounts to the same thing. So over the course of a year, Ursa Minor is also going to rotate counterclockwise around the North Celestial Pole. So that's how you can fiddle around with it. So you can either change the date or you can change the time, and then just see how the constellations shift throughout the course of one night or over the course of an entire year. Well, shall we take a look at question 15?
Sure.
Okay. Yeah, if you scroll all the way down, you see a list of the planets. And I think, we've just switched to April, so let's just switch back let's switch back to January. So we're back to January. Let me update this. Okay. And we could, oh, nice. See here on the right, if you see the column on the very right, it actually tells you if it's up or if it has set. So if we pan around the sky above our horizon, we should be able to see Uranus, Jupiter, the moon, and Venus, and all the other planets and the sun have set, and also including dwarf planets. Let's click on Jupiter. And then it brings our sky map, brings us directly, puts Jupiter in the center. So this is the symbol for Jupiter. I don't think it's going to show us our horizon, but it's going to show the coordinates of Jupiter. So it's 2 hours, 1 minute, 37 seconds right ascension, and positive 11 degrees, 12 arc minutes, and 31 arc seconds declination. Okay, so if we were to pick Jupiter, and the date would then be today, if we look at the table that we need to fill in, we would use the 2 hours, 1 minute, and 37 seconds as right ascension, the 11 degrees, 12 arc minutes, and 31 arc seconds as the declination, and the constellation. If we look at Jupiter, do you see those green boundaries? Those are the boundaries of the constellation. And anything that is inside this green boundary here is going to be part of the constellation of Aries. So that means Jupiter, since it is inside this boundary, is actually in the constellation of Aries tonight. It's at the edge, but it's still within that boundary. So you would put down Aries for the constellation. And if we scroll back down, we see, it doesn't say that Jupiter is up. But from the earlier view, from the horizon view, we have to go back to the horizon view, and then it actually told us whether it's up or whether it's not up. Okay, we remembered it was up. So then, let's see, we go. The instructions that are given in the lab manual on page 110, they're actually for the Sky 6, which is the program that they use on campus. So for our program here, the best thing to do is just to follow our WIMBA session here. Okay, so the next thing we want to do, so for tonight, we know the right ascension, the declination, and we also know that it was up, and we have just verified the constellation to be Aries. So now what we're going to do is we're going to go back up to your sky. So we're going to reset it for that. Then we're going to reset it for the nearby city, which was Atlanta. Oh, just passed it. Okay, and we want to observe 1 month from now for the second row of the table. Okay, so 1 month from now, So we do it, put it back on universal time. That would be February 28th. So we just change the month to February 28th and then click Update. And scroll back down to Jupiter. Okay, so we can click on Jupiter again, although it tells us all the information right here. So February, except for the constellation. We need to look up the constellation. So click back on Jupiter. And now our aim point is 2 hours, 1 minute, 37 seconds. Wait a minute. That's, January 28th again. Alrighty then. So that's why you always want to double check what the Your Sky program displays in terms of what date it has and what time it has. So let's click that back to universal time, set that back to February, and click Update. Okay. So now we click on, we actually see Jupiter here. This is Venus, and here's the moon. Okay, but let's click on Jupiter so we can actually change the aim point and put Jupiter back in the center. So the coordinates now have changed to 2 hours, 13 minutes, 49 seconds, right ascension, and 14 degrees, 9 arc minutes, and 12 arc seconds declination. So if we look at the constellation, a month ago, so right now, Jupiter was at the very edge of Aries, and now, a month later, on February 28th, it has moved a little bit more towards the center of Aries. So it would still be in the same constellation, and so we need to check if it's visible. That's a little bit cumbersome with this particular program, so we have to go back to Your Sky, set for nearby city. Go back to Atlanta. View horizon. Of course, you see how the program has reset back to January 28th, so we have to move that back to February 28th. Click Update. Okay, and then if we go back down here to Jupiter, so you could also copy down those right ascension and declination. But yeah, Jupiter would be up. And just for kicks, let's see if we can pan around and find Jupiter in our horizon side. Okay. Here. Oh, well, that's Mars. Okay, still haven't found Jupiter. Okay, here it is. Okay, so this would be Jupiter, and it's indeed above the horizon for February 28th. Okay, and then the last row in the table, if for question 15 would be finally change the date to 6 months from now. So let's go ahead and do that. So tonight would be January, so 6 months from now then would be July. So let's change this to 7 for July and update. Okay, and let's see if we scroll all the way down to our table of planets and objects. Okay, so here we see the coordinates for Jupiter, 4 hours, 32 minutes, 11 seconds for the right ascension, 21 degrees, and 7.3 arc minutes. I guess they don't do the seconds here. But it definitely has set. So we wouldn't be able to see it at 9 p.m. on July 28th. And if we pan around, we wouldn't be able to see it. We could go all the way back around to west and south and north and all that, and we wouldn't be able to see it.
So for the constellation, we wouldn't put anything there if it's not visible?
Well, no, it would still be the constellation, so we need to click on it, and of course it has reset, as you can see. So we would click on Jupiter and then adjust the date yet again here to July. That's sort of the tricky part about this program. Whenever you adjust something and update it, then it might go back to a default on something else. So now we've adjusted it to July, and we have our view on Jupiter. Or we used to. Well, we have to pan around now. Okay, now we have July. Okay, here's Jupiter. Oh, now it adjusted back to Jeez. Okay, let's try this again, and then I'm going to pan around. Actually, what were the coordinates that we had? See, 4 hours, 32 degrees, and 21. Okay, this is at 2 hours, so 3 hours. Let me just go over here, click on the left side. Okay, and here's Jupiter. Okay. Let me center it, so if you click on whatever object you want to see, the program puts it in the center. Okay, so this, now, in which constellation is Jupiter now?
Taurus.
Yeah, it would be in Taurus, so now you put down Taurus. And here's the outline of the constellation of Taurus. So yeah, Jupiter is smack in the constellation of Taurus. Okay, so this is sort of how you fiddle around with that program. There are 2 more questions. Yeah, let's just quickly talk about those. Okay, well, yeah, someone had asked on the bulletin board which sky map to use. In my narrated audio slides, I've used the autumn skies, but since this is the spring semester, you could either use, the winter skies because we're doing the lab while it is still winter, or you could use the spring skies. So it really doesn't matter. I'm trying to think.
Is there a key, like, for what planets, what, like, the yellow, we know Jupiter, how would we know that? And how did you know, like, the little white with blue was Venus?
Oh, yeah, those are the symbols for the planets. Actually, my cell phone is ringing. If you don't mind, I'll get it real quick since it's already after 9, and then I'll be right back. I'll just tell the person to hang on. Yeah, okay, I'm back. Yeah, it's a friend of mine actually. I'm gonna call her back when I'm done here. But she has called for the second time, so it was something that's a little bit urgent, but it can wait a little bit more. Okay, yeah, you were wondering about the symbols. Each planet has a particular symbol, and that is the symbol for Jupiter. Now, another way to find out which planet you're talking about, if you click on any of those planets here, for example, if we click on Saturn in this list, it'll put that planet into the center. So then you know whatever is in the center, that is the planet with that symbol. So, since we clicked on Saturn, it has put Saturn in the center. So Saturn is this symbol. It sort of looks like like a squiggly H. You can see in the symbol here, it also has a little bit of a ring, or like what could be interpreted as a ring seen edge on.
Oh, thank you.
Yeah, and then you can just sort of go through and click on. Well, Neptune would be the spike of, or the fork. I don't know, that fork of Neptune. Venus is the female symbol. Mars is the male symbol. This would be the. Oops, wait a minute. Yeah. This would be the sun. The moon looks like a crescent. So yeah, you can click around with that a little bit. So that's how you can find out. Okay, well, yeah, let's just quickly talk about if you take, look at that particular page. Let's use the winter skies, and you're looking at a sky map on page 114, which shows the winter skies. So late December or early January, what we would see at late January at 9 p.m. So this is probably what we would see right around now if we were to look up at the sky. And this is sort of the view where most of the constellations have been labeled, and even some of the stars have been labeled, but some of them are not labeled. You know, they're so for example, on the lower left is a constellation that is just called B. Then there's another constellation near the center that is called A, and then above that is a constellation that is labeled C. So we have to find a match of those constellations that are labeled with capital letters with the sky map, that, you know, the program that we're using here on the computer. And then there are a couple of stars that are pointed to with arrows. For example, D is a star in Orion, the brightest star in Orion that is pointed to by the arrow, and E is another very bright star, or the brightest star in the constellation, that is just labeled with B. So we have to match those up now with what we see in our program. And in order to do that, we'll go back to Up to Your Sky. And we'll just click on Make Sky Map, because it doesn't really matter what city we're looking from. You know, we just want to find what those constellations are. Well, if we look at our winter skies, you know, we can tell that Orion is already pretty close to that one constellation that we're looking for with the unknown constellation name and the unknown star, but also one of the stars that we're looking for is in the constellation of Orion. So let's find Orion in our sky map, and it's actually just off the edge here. So let me go ahead and click on that. Okay, so now our sky map has zoomed in on Orion, on the constellation of Orion. So you can probably see, you know, which one of the stars is the unknown star. Which one does it point to? Star D. So it's pointing directly at this one here, which is, well, it's kind of hard to pronounce, Betelgeuse. I mean, you've probably heard it, but this is how it's really spelled. Okay, so star D would be Betelgeuse, and then, well, it looks like that we're pretty much looking at a similar view. So let me scroll down on the screen. And, you know, since this program might have the dots in the constellations connected a little bit differently than, you know, the sky map from the lab manual, but the constellations themselves should look fairly similar to the patterns of stars. So if we look down on our lab textbook sky map, you know, it looks like the constellation, the unknown constellation that we need to figure out what the name and the brightest star is on the lower right. So let's click on the lower right here, and it looks like this one might actually be it. Yeah, and it looks sort of like the constellation that is constellation B is this one right here. You know, because there's this cross, sort of, kind of. Yeah, so we're looking at, yes, Canis Major, and the star would be Sirius. So maybe, you know, if you now move around, back up, you know, you keep going up to the right, then you might actually come across the constellations A and C. So you would just kind of pan until you get there. So now we're back to Orion. And you probably have to pan in this direction, sort of. I mean, you could also zoom back out. You zoom out, zoom in, and play around with that. So this is how you figure out question 16. And yeah, let's quickly go to question 17. So here it says to pick a particular object. So for the fall skies, you would pick M31, which actually happens to be the Andromeda Galaxy. But for winter skies, we want to pick M45, which is the Pleiades. So in this case, we want to go to catalogs. I think we have to just go back to the general view. Okay. Go back up to your sky and scroll down to object catalogs. Here it is. So this is another way where you can get to planets, constellations, but the M, all these objects that are listed in 17 have an M number. So M31, M45, M13, those are Messier objects. So the M stands for Messier. So that means we want to go to the Messier catalog of non-stellar objects. And then we can scroll down to M45. Wait a minute. So we click on that. Well, it turns out if you look at this row here in the table, it already tells you what it is. It's the Pleiades. You know, it tells you what the constellation is in, so you can write down Taurus. You know, it gives you the right ascension and declination, so 3 hours and 47 minutes would be the right ascension, and 24 degrees and 7 arc minutes would be the declination. But, you know, to see it in the sky map, you can click on it, and it puts it in the center, and of course, it's sort of right on top of something else. So it would be right here in the center of the sky map. Yeah, but you can see it's in the constellation of Taurus. And if you scroll up, you see this is at 3 hours, 47 minutes, right ascension, and 24 degrees and 7 arc minutes declination. So that would be for question 17.
What does the paragraph name mean on that question?
Let's see, say again.
I'm sorry, it says, what's the paragraph name? What does that mean?
Let's see, where do you read that?
Well, my question 17, it says paragraph name, then it says constellation, right ascension, and declination. Does anything go in that blank where?
Okay, you're looking at the yeah. Let's go to the lab. You're looking at the lab assessment, right?
Yes.
Okay, yeah. Let's take a look at that. I think I've just put some stuff into the. Oh, okay. Here we are. Oh, okay, name right here. So the first line in the answer is name, and then constellation, right ascension, declination. Yeah, I wanted you to put in, you know, if we do the winter sky here, then you would just write down M45 or Pleiades, you know, the object that you picked. Because if I'm teaching the lab in the summer or in the fall, you know, then people would pick the M31 in the fall M31 Andromeda, they would put down the name. So it would be what you read in the table as the name of the object. So Andromeda, Pleiades, I don't know if M13 would have actually a name. So that's what you put in there. And then the constellation would be Taurus, and then the right ascension and declination, what we talked about.
Thank you.
Okay, you're welcome. Yeah, let me get back to the Wimba screen. Yeah, if you don't mind, I'd like to jump off now and get back with my friend because I think her father is sort of about to die. A little bit sad, but I mean it was. Well, I mean he was already ailing, so it's not a surprise, and she has already talked to hospice a week ago, so it's not really a surprise, but she probably would have thought that he may have lasted for another month or so. So yeah, let me just jump off and get back with my friend. But thanks for coming tonight, and I'm going to post the link. I'm going to open up the link to the session quickly so that the other students can also take a look at this and listen to everything. All right.
Thank you so
I'm going to stop
much.
the archive. Okay, you're very welcome.